Welcome back, Math Marvels. We're going to continue our work using percents and talking about percent increases, and specifically, we're going to talk about percent increases for certain services like tips. And when do we tip and what does that mean? And how is that different, or is it any different than adding a tax? So let's jump in with our first problem in the model. The cab ride from JFK Airport to Fordham Road is $65. Joey tips the driver 15%. How much did he tip? How much was the ride with the tip? So a tip is something that you give as an additional cost that you provide for a service. And oftentimes the standard is 15% in this country. There are other countries where you don't even tip, where it culturally is almost considered rude. But here in America, for certain services, like if you go to a restaurant, you offer a tip. Okay, so jumping back into here, this is what we want to know. How much did Joey tip the driver? We want to know that amount. We know the percentage. We want to know how much that actually was, and then how much he paid altogether with the ride and the tip. Here are our facts. We have our original amount, and we already know at this point that when we think of original amounts, we consider this the 100%. It's our starting point. And we know that the price increased by 15% from the $65. So he added an additional 15% of 65. And we know that 15% is a ratio. We've done this so many times. So we already know what we're going to start off with. We're going to use math to set up a ratio table. We're going to add the percent as our given ratio, 15 out of 100. And we're going to use our 65 as the original amount. So that's going to be in the same row as the 100. So our next ratio is going to be n over 65. And finally, we're going to cross multiply to figure out what that 15% is. Now, why can't I just add them together if the whole price is going up 15%? Like, why can't I find 115%? Because we want to know how much that 15% is. It's in the problem. We want to know how much the tip was, not just the tip plus the price. And that's why I'm finding out 15%. But then after we know that, for the second part of the problem, we're going to add the tip to the 65 to figure out the total cost. So that's our plan. You're going to see it in a second. Hit pause so you can jot it down and follow along. All right, I'm drawing my table using math. And as always, we have our 15%. That's what's being tipped. So that's our first given ratio, 15 out of 100 on our part to whole ratio. And we want to know, well, he paid $65. So that's not the 15% tip. That's what the entire bill was before the tip. And we're going to add 15% on top of that. So that's our number. Let's set this up. 100n is equal to 15 times 65. And we're going to have the number 975. We're going to divide by 100. And again, let me give myself space so that I can write my sentence at the end. And so our number is equal to $9.75. And again, what math are you not seeing? You're not seeing me go to the left to divide by 100. But that's how much the tip is. So that's how much the tip is. Now there's a second question. How much would the ride be with the tip? So we're going to take our $65 and we're going to add the tip. And we're going to add these together. And the whole ride will cost $74.75. So let's add this into our sentence. Joey's cab ride was $65 before tip. He added a 15% tip, comma, or $9.75. So the final total is $74.75. Okay, let me reread that to make sure it makes sense. Joey's cab ride was $65 before tip. He added a 15% tip or $9.75. So the final total is $74.75. So the only change I'm going to really make is just in language. This final total was, just because I use past tense throughout everything. All right, hit pause and jot this down into your notes. Fantastic. We have one more to go. Let's jump right to it. Okay, we're going to jump into problem 2. There's going to be a little bit of a difference that I want to really highlight in this problem. So let's read it first. Domino's decides to raise their prices 5%. If pizza costs $14.99, what is the new price of the pizza? There is 8% sales tax. How much is the pizza with tax? So we're trying to figure out the new price of the pizza and then the tax. There are 2 increases. So what is 5% higher, 5% more of $14.99? And then whatever that is, we want 8% of that. So there are 2 things happening here. So what do we know? We know the original amount, and we know there are 2 increases happening. So here's the difference. I'm going to try and highlight it in the plan. The first one is I'm going to use math twice. First, I want to find out the new price. So before, remember how in the last problem we found the price, the tip separately, like what is 15%, and then added it on. Here we're going to do it in one step, because I want to know what is the new price. So I don't want to know how much it went up. I want to know what is that new price. So instead of figuring out what is 5% of $14.99, I'm going to do something new, and I'm going to find what is 105% of $14.99. And that's going to just give me the new price in one step because it's adding it in. Okay, and I can do this because I just want the new price altogether. So I'm going to do it in one step. If we had asked how much more is the price, then I would only want 5%. But I want the new price, so I'm going to figure out 105%. So that's what we're going to see in the table. And then I want to know what is the price with tax. So again, instead of finding 8%, I'm going to find 108% of that new price. So I'm trying to be more efficient in my work. This is going to feel a little funny now. Just watch when I'm doing it and ask yourself, does this make sense? And how would this method serve me as I'm doing problems like this? We know our percents are ratios. So we know how to write them: 105 over 100, 108 over 100. And we're going to do our cross multiplying to find each new increase. Okay, so hit pause so you can see this in action. I'm so excited to show you this plan in action because we have 2 changes and we want to make this a more simplified problem. So let's start with first adding the new price, the 5%. And then adding the tax. And thinking about percent increase in a new way. We know, here's the original amount, $14.99. And we're thinking about this as a part to whole. So this is 100%. And we want to know what is 105%. I'm adding it in here rather than finding 5% and then adding it at the end. So let's see what this looks like. Here's our number. So we have 100N is equal to $14.99 times 105. So let's use our calculator to minimize mistakes. And we get 100N is equal to 1,573.95 cents. Now we're going to divide by 100. And we get $15.70. I'm going to round that instead of 73 cents to 74 cents. So our new price is $15.74. That's our new price. Now remember, this is plus the 5%. So that's what this is. All right, and now we're going to do it again, another part to whole relationship. So we're going to put the 1574, and we're going to pretend this marble, that's the new 100%, because that's the new set price. And I want to add 8% to that. So let's put in an 8% increase, so 108. So we still get 100N. And this time we're going to do 108 times 1574. So 108 times 1574, and I record everything, is equal to, let's just put it in, 1,699 and 92 cents. We're going to divide both of these by 100. In case you want to see, 1699.92 divided by 100, and we get N is equal to 16.9999. So we're going to just round that up to $17. So that is our new price with our sales tax. Hit pause so you can jot this down in your notes. And now for our last question. Rick bought a new seat for his spaceship. He paid $627 and 4.5% tax. How much did he pay after tax? Round to the nearest cent. So let's think for a minute. Do I just want how much it went up, or do I want the whole new price? Do I just want the 4.5%, or do I want the 4.5% plus the $627? Well, I want to know how much he paid after tax, so I want the whole thing. And that's what we're asking. How much was the new seat with tax included? That's an increase. We know the original price, we know the percents. So in this case, I am going to use math, but I'm also going to look for 104.5% of 627. So I'm going to do it in one shot because you saw how much faster that was. And we know our 100% is 627. So we're going to set up our table like that, and we're going to figure out the unknown in this problem. We'll cross multiply. We will definitely be using calculators because we have to do some rounding at the end to the nearest penny. So we're going to go to the thousandths place. So hit pause so you can jot this down and then watch as I walk through the problem. All right, we're going to set it up in our nice, quick, easy way where we want it an increase of 4.5%. And our original price is $627. So it's going to be a little bit more than $627. All right, let's put in our numbers here. We have 100N is equal to 627 times 104 and 5/10. And we get 65521 and 5/10. And I'm going to divide both of these by 100. I already know I'm going to move my decimal just once and twice. So N is 655 and 215. But that doesn't make sense for money. We're going to round this to the nearest cent, which means 655 and 22 cents. And let's add this in there, the new price. With tax is equal to 655.22. Well, that's it, math marbles. Look at how much faster that is than before. We were finding what is 4.5, what is that part, and then adding it on. We were doing that. Now it's a lot faster because we're just putting it right here into our work. We're adding the increase directly in there, and it makes it faster using math. All right, math marbles, we will see you in the next lesson. Take care.